Good morning, students. Today we'll see about the Rjcl law. In the last period, we have discussed about the effect of various factors on solubility. In that, nature of solute and solvent, effect of temperature on the solubility, and the effect of pressure on the solubility. Now today we'll discuss about the vapor pressure of solutions of liquids in liquids. Consider a binary solution of two volatile liquids A1 and A2. In that, when the solution is placed in a closed container, both the liquids vaporize. Eventually, an equilibrium is established between the vapor and the liquid phase. Both the components are present in the vapor phase. The partial pressure of the components are related to their mole fractions in the solution. This relationship is given by the Rjcl law. When we are considering the two volatile liquids A1 and A2, they are taken into the container. Both the liquids vaporize and eventually they are in the equilibrium phase. Both the components are present in the vapor phase. The partial pressure of the components are related to their mole fractions, and that relationship is given by the Rjcl law. The law states that the partial pressure of any volatile component of a solution is equal to the pressure of the pure component multiplied by its mole fraction in the solution. Suppose that a binary solution of two volatile liquids A1 and A2. The P1 and P2 are their partial pressures. P1 and P2 are the partial pressure. And X1 and X2 are their mole fractions. X1 and X2 are the mole fraction. A1 and A2, a binary solution. P1 and P2 are the partial pressures, and X1 and X2 are the mole fractions. Then, according to the Rjcl law, we can write the P1 is equal to X1 P1 naught and the P2 is equal to X2 P2 naught, where P1 naught and the P2 naught are the pressures of the liquids A1 and A2 respectively. According to the Dalton's law of partial pressure, the total pressure above in the solution is P is equal to P1 plus P2. Total pressure का ऐसे हो P1 plus P2, but P1 is equal to X1 P1 naught and P2 is equal to X2 P2 naught according to the Rjcl law, where A1 and A2, these are the components in the binary solution, where the P1 and P2 are the partial pressures and X1 and X2 are the mole fractions. Then according to the Rjcl law, we can write P1 is equal to X1 P1 naught and P2 is equal to X2 P2 naught. But according to the Dalton's law of partial pressure, the P is equal to P1 plus P2. Then P is equal to, we will put these values of P1 and P2 into this equation. P is equal to P1 naught, P1 x1 naught, P2 x2 naught. Since x1 is equal to 1 minus x2, means we can write this equation. It can be written as P is equal to P1 naught into, instead of x1, we can put the value that is 1 minus x2 plus P2 x2. Then P1 naught minus P1 x2 naught plus P2 x2. Then x2 by P2 naught minus P1 naught x2 plus P1. Because P1 naught and P2 naught are the constants of plot of P, whereas x2 is straight line, as shown in the graph. Also, the graph also shows that, or the figure shows that, the P1 whereas x1 and P2 were x2, according to the equations, are the straight lines. And if into your book the graph is plotted into that, you can say that the two straight line graphs are formed. म्हणजे या पद्धतीने हे इक्वेशन जे आहे हे रूल्स लॉच आपल्याला या ठिकाणी इक्वेशन आपल्याला म्हणजे अकॉर्डिंग टू द रूल्स लॉ what's the statement of the rules law? The law states that the partial pressure of any volatile component of the solution is equal to the vapor pressure of the pure component multiplied by its mole fraction. हे या ठिकाणी रूल्स लॉचं स्टेटमेंट आपल्याला या ठिकाणी या पद्धतीने एक्सप्लेन करतात. Then we have to talk about the ideal solutions and non-ideal solution. Ideal solution and the non-ideal solution. Ideal and non-ideal solution. Ideal solution may obey the rules law or entire range of concentration. No heat is involved or absorbed when the two components forming an ideal solution are mixed. Thus, the enthalpy of mixing is zero. Hence, the delta max is equal to delta max means enthalpy is equal to it's zero. Because no heat can be released or absorbed when the components forming an ideal solution. Therefore, the enthalpy of the mixing solution is zero. There is no volume change when the two components forming an ideal solution are mixed. Thus, the volume of an ideal solution is equal to the sum of the volumes of the two components taken for the mixing. Means delta B, that is now. There is no change into the volume in the ideal solution when the two components of the solution are mixed together. At that time, there is no change into that. And the delta B, the volume of the component is no change. There is no change when the components forming an ideal solution. In an ideal solution, solvent, solute, and the solvent molecular interactions are the comparable interactions. The vapor pressure of ideal solution is always lying between the vapor pressure of the pure components. This is important to understand that the perfectly ideal solutions are uncommon and solutions such as benzene plus toluene behave nearly the ideal आयडियल सोल्युशनच्या बाबतीमध्ये काही महत्त्वाच्या बाबी आपण जर पाहिलं तर at that time we can say that the ideal solutions obey the rules or the entire range of the concentration. The ideal solutions, there is no heat, evolve or absorb. Hence, there is no change in that now. In the ideal solution, the component forming the ideal solution, there is no change in the volume. No change in the volume. And the ideal solution, solute-solvent, solute-solute and the solvent-solvent molecular interactions are compatible. These are the few features of the ideal solution. The vapor pressure of ideal solution always lies between the vapor pressure of the pure components. Hence, the perfect ideal solution can give the example that is the benzene and the toluene. They have nearly the ideal solution. On the other hand side, when we are talking about the non-ideal solutions, these solutions do not obey the rules or the entire range of the concentration. The vapor pressure of these solutions can be higher or lower than those of the pure components. Deviation from the rules law, these solutions show two types of the deviations from the rules. The solution in which the solute-solvent interaction, intermolecular interactions are weaker than those between the solute molecules and the solvent molecules, exhibit the positive deviation, and the vapor pressure of the such solutions are higher than those of the pure components. म्हणजे याच्या आयडियल सोल्युशनच्या विरुद्ध बाजूला आपण जे काही बाबी पाहतो त्या these are the non-ideal solutions. About the pressure, about the concentration of the components in the entire range means they do not obey the rules. About the heat, म्हणजे या other बाबी ज्या आहेत, these are default from each ideal and non-ideal solutions. The vapor pressure of these solutions can be higher or lower than that of the pure components in case of the non-ideal solution. म्हणजे ideal solution आणि non-ideal solution च्या बाबतीमध्ये या वेगवेगळ्या फरक आपल्याला या ठिकाणी भेटून येतो. Then when we are talking about the colligative properties, the colligative properties of the non-electrolyte solutions, the physical property of the solutions that depend upon the number of solid particles in the solutions and not on their nature are called as the colligative properties. What's meant by colligative properties? The physical properties of the solutions that depend on the number of solid particles present in the solution, but not on the nature. म्हणजे किती नंबर पार्टिकल्स प्रेझेंट आहेत त्याच्यावरती डिपेंडंट आहे, बट they are not dependent on the nature of the particle. Such properties are called as the colligative properties. In that, vapor pressure lowering of vapor pressure, elevation of boiling point, depression of freezing point, osmotic pressure, these are the colligative properties. म्हणजे colligative properties कोणत्या आहेत? म्हणजे या प्रॉपर्टीज मध्ये त्यांच्या नंबर ऑफ पार्टिकल्स वरती त्याची व्हॅल्यू डिपेंडंट आहे, बट दे आर नॉट डिपेंडेंट ऑन their nature of the particle. Such properties are called as the colligative properties. Vapor pressure, lowering vapor lowering, boiling point, elevation, freezing point, duration, and the osmotic pressure. These are the qualitative properties. While dealing with the qualitative properties of the non-electrolyte solution, the relatively dilute solutions with the concentration of 0.2 molar or less are considered. म्हणजे या ज्या काही क्वालिटेटिव्ह प्रॉपर्टीज ज्या आहेत या क्वालिटेटिव्ह प्रॉपर्टीज मध्ये कोणकोणत्या आहेत? लोअरिंग ऑफ वेपर प्रेशर, एलिव्हेशन ऑफ बॉइलिंग पॉइंट, डिप्रेशन ऑफ फ्रीजिंग पॉइंट अँड ऑस्मॅटिक प्रेशर्स. That we will see one by one in the next video. Okay, thank you.